Hello, we are going to be making our HR diagrams, and I'm just going to go over how to label and set up our page. So the first thing, you should be on page 29 in your science notebook, and we are going to write the title, HR diagram. Just like our other pages, we're going to add the date. It should be the 8th. And this is slow one. We're identifying stars here by their data. So yesterday you did the card sort, and today we're going to add that graph to our notebook, and we're going to label the important parts of this. So this HR diagram, this is all the stars we can see in the sky, and we're going to add color, and we're going to show how we classify them. So I did that based on this picture here. This is linked in Google Classroom if you want to look at just this as we go along. But we're going to label all our axes. I'm going to show you some of those important stars and some categories of it, and then we're going to color them at the end. All right, so we're going to start. This is the HR diagram. It stands for Hertzsprung-Russell diagram. Those are the two astronomers who created this graph. The chart has 4 axes, but it is basically temperature on the X, horizontal, and brightness on the Y. And they're just 2 ways of saying the same thing. So the X-axis on the bottom, this is surface temperature of the star in Kelvin, and they do this usually by looking at the light that each star emits and using infrared to see how much is really given off. And it goes all the way from 40,000 to 25,000 Kelvin. On the y-axis, we have absolute magnitude, and then on the other side, we have luminosity. And our sun is 1 luminosity. So on this, these are both measures of brightness. Luminosity is just bright, it's just how bright something can be. Absolute magnitude is a little bit easier of a thing to notice. It's more objective because this takes into account distance. So absolute magnitude is like absolute in math when you have just the distance away from 0. In this case, it's distance away from brightness. So our sun is at 0, and the dimmer stars are here and the brighter stars are here. And absolute magnitude is important because stars are different distances away from Earth. The further away a star is, that affects how bright it is. So absolute magnitude takes into account that distance and tells you the distance, or tells you the brightness from 10 parsecs away, which is a specific distance in space. All right. Then on our top one, this is something called spectral class. And this is a weird thing. So we say stars are A or F or G because first their spectral class was determined just based on stars that you could see from Earth. And this was in like the 1800s. This was way before we had things like absolute magnitude or how to define it. So they were all alphabetical based on brightness and temperature. And then we figured out this absolute magnitude, and that spectral class changed from A, B, C, D, E, F. They had to reorganize them based on brightness to these O, B, A, F, G, K, M, this new set. All right, so those are our axes. now we are going to add some important categories that you need to add. So the first category is these main sequence. So this main sequence is the diagonal from here to here. So I'm just going to add these lines and label this as main sequence. So these stars are in their prime of life. They are doing nuclear fusion. That means they have enough energy to make new atoms and combine them. So they're going from helium to hydrogen or whatever size they are. And a star will go through their main sequence as they go through their life. So the really early stars are young, they are hot, they are bright, and then as they get older, they lose some of that energy, they lose some of that brightness till they go down to this area over here, which is where they die. At the top, we have some special stars. These are called supergiants. They're really big. And then we have regular giants. These are down here. And then we have these guys over here that seem like outliers, but these are just little dead guys. These are just white dwarfs. So they're still super hot, but they're really dim. And then this arrow is just to show that the temperature is increasing from right to left instead of the usual left to right. It's just kind of a weird thing about this. All right, then we're gonna get some colored pencils and we're gonna label some stars here. So you're gonna need red, white, and yellow, oh, and blue. This can be colored pencils. This doesn't have to be crazy coloring. You'll see that mine is not very in-depth. So first we have our brightest stars. These are blue. They are here. And these guys are blue. And see, I'm not doing a crazy good job on coloring. If you want to, be my guest. I'll never stop you. All right, so our hottest, most energetic stars are blue over here. These ones are white, and then we go into some yellow ones that are in this main sequence. So they're losing some energy. Remember on our visible light spectrum that yellow is dimmer, has less energy than blue. Blue and violet have the most. Just coloring these yellow all the way here. And let's label some stars as we go. So we have, let's use red for this. We have Vega, that's a pretty big star. We have Sirius, that's the dog star. It's pretty bright. We have this one right here. This is about midway through. This one you should know. This is our sun, right in the middle of its life cycle. And then up here we have Polaris. That is the north star that we see. And then we're going to need some red for these upper ones here. The red guys. And then all of these are red down here. Our little dim guys. And these odd ones, so this big one is one of the biggest ones, the brightest ones that we see. This is something called Betelgeuse. And it's spelled a little bit differently. It's Betelgeuse. And then we have this one down here. Our last star we're going to label. This is something called Proxima Centauri. And that one is our closest star that is not the sun. All right, so this is our HR diagram in all its color and glory. If you can't read my labels very well, this is a picture in Google Classroom from our HR diagram that we looked at yesterday that looks just like this. And again, when you're done, this is going to go on page 29 in your notebook. And don't forget to update your table of contents. Bye.